Hello, dear student. How are you? I hope you all will be fine. I'm also fine. Thank you. Welcome to the Science Group. Today we will discuss one new mechanism, that is Claisen rearrangement. In previous lecture I explained you the Claisen condensation, but in today's lecture I will explain you the Claisen rearrangement. In this in this mechanism, the phenyl groups are used. That is aromatic aromatic groups are aromatic, that is attached with the that like ether, that will be found like ether groups, and that is also the double bond groups. So this position, this aromatic compound will be present. So in this aromatic compound, like in COP rearrangement, here is some rearrangement will be occur like COP rearrangement. So I will be explain you COP rearrangement in one separate lecture, because co-rearrangement is itself one separate lecture. So okay, let's start the topic, that is aromatic compounds. In this compounds, the bond between oxygen and carbon, the bond between this oxygen and this carbon, that will be shift towards here, means it will be bonded between carbon and oxygen double bond, but here is already carbon covalence complete. So that's why this one bond of this carbon will be break down. So this why this bond will be break towards here, and it will be produce bond between here in this two carbon, but here this carbon has also completed their covalence. So that's why this bond will be break their bond, so it will be break towards here, and here it will be form double bond. So it means that one double bond will be present between oxygen and carbon like that, and this double bond will be shift here and present, it will be produce a single bond between this carbon like here is this, but this double bond will be shift here like this. So this is non-aromatic compound produced. This is non-aromatic because aromaticity is not maintained. So this is aromatic change into non-aromatic, but this process, this co-rearrangement will be take some heat, that is endothermic heat, means you will provide heat up to 180 degrees centigrade temperature you should be provided. So that's why the aromatic compound will be converted into converted into non-aromatic compounds. I hope this will be clear. In this mechanism, bond formed and bond broke as a C1, C6. So that is some notation, that is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So yes, C1 and C6, that is carbon 1, that is carbon 6. It will be bond formed like here. Yes, a bond is formed in between. While which bond will be broken? Bond broke C1 and C2. C1 and C2, this double bond will be broken. It will be shifted towards here. While C4 and C4 and C5, here it will be one double bond, single bond is present. So one double bond will be produced here like this, between 4 carbon and 5 carbon. Yeah, but 5 and carbon 6, so that pi bond will be break down, carbon 5 and carbon, yes, this pi bond will be break down towards here. Yeah, I hope it will be cleared. Here in C2O, that is carbon number 2 and oxygen, here will be double bond produced like that, as I explained before. But which one will be break? So C4 and O, that is carbon number 4, that is oxygen. So this bond will be break towards here, and here will be double bond produced. I hope it will be cleared. Still, if you have any confusion in this part 1, you can ask me in comment section, as well as you can ask me in my personal WhatsApp that I put in the description box. You can get from there. Part 2, atomization to restore aromaticity. Once again, we should need to restore the aromaticity, but how aromaticity can be arranged? Aromaticity can be restored by atomization. Atomization is the phenomena in which proton transfer occur from the one proton transfer as well as double bond will be shift towards with each other, replace with each other. So that's why here it will be present in the some acidic medium or some basic medium. Here we use ether. So in the presence of ether, this proton will be shift here. This proton will be abstracted. This proton will be abstracted by ether, by, or you can say that is solvent. That proton will be abstracted by solvents, and this bond between carbon and hydrogen, it will be shift towards here double bond. So here double bond will be produced, but here carbon covalency is completed. So that's why one bond between carbon and oxygen, one bond of this carbon will be break down. So that's why the carbon between oxygen and carbon, this double bond will be break towards oxygen, and oxygen will get negative charge. Oxygen will get negative charge. So that's why here it will be double bond produced. But in this case, here is electronegative, here is negative charge on oxygen. So in the presence of 180 degrees centigrade temperature, by providing 180 degrees centigrade temperature, the compound that was produced by side products, like that is ROR and one H when that was here is it was added. So that's why that H will be again protonated this compounds. So oxygen has negative charge, this negative charge will be attack on carbon, and this oxygen will become or you can say that this solvent will become neutral. So that's why one H will be produced, one H will be attached with this oxygen. So that's why that will be final aromatic product producer. And this phenomenon is called atomization, when one proton shift from one center to another center, and also double bond will also replace, or double bond will also shift. So double bond shift from here to here, while this single bond or this proton shift from here to this oxygen, like that. So this is also, this phenomenon is also called atomization, and atomization restore the aromaticity back. I think it will be clear. Still, if you have any confusion, if you have any question in the topic, you can ask me in the comment section. Okay, also please subscribe my channel. It'll make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my students. Very best of luck.